And HVAC 6. Why are we ignoring the heat load from the number of occupants in this question? I understand you need to assume an activity level, table 911, human cooling loads, but even if that many people are assumed seated and at rest, as in seated at a theater, it represents a pretty significant load. So this problem was about finding the total cooling load in a building. And I gave you some information about the fact that it's a theater and how many occupants there are. But then when it came to the cooling load calculation, we left out the load provided by those people out of it. Why is that? Well, there are definitely problems, and there's other ones in the HVAC module that you may have already come across or you may come across later, where we don't have all the information about the room conditions and the outside air, like what we're trying to achieve, delta T's for the system. So we have to go down into the nitty-gritty detail of calculating the internal loads. We have to look at everything that's there. We have to look at lights, we have to look at equipment, we have to look at people, and build it from the bottom up and then figure out how much cooling do we supply. But sometimes we don't have to do all that. And this problem is one of those cases. Why? Because the internal and the external state were fully defined. We knew the internal load, so we knew what needs to be the temperature and moisture level inside the space, and we knew the same for the outside air. In other words, both are fully defined states, which means we could find the enthalpy for both states, 1 and 2, let's call them, and then we could find the change in enthalpy for both of those states, and then we could jump straight to our favorite rule of thumb, one of our favorite rules of thumb, the total cooling rule of thumb. We could just say Q dot equals 4.5 CFM delta H, where delta H is H2 minus H1, or H outside minus H room, however you want to think about that. But both of these are fully defined. We can identify both of those. If we know the CFM, we can find the total cooling load. The reason I had to give you the number of occupants was because the CFM was not fully defined at the beginning of the problem. The CFM was partly dependent upon how much ventilation air needed to be introduced, and that's a function of the occupants. So that's why I told you the type of space and the number of people in the space, so that we had a way to come at that CFM. So go back, rewatch that video solution with special attention on how we use the information about the type of space and the number of occupants to find the CFM. And everything else about the problem really just kind of stays quite simple and sticks to this rule of thumb. And it's a bit of a game as you go through these practice problems, because sometimes you wish a problem was simpler. Like once you know, it's like once you have this in your pocket, you want to use it all the time. Like if this is a hammer, everything starts to look like a nail. There are definitely problems that are more interesting than just applying a rule of thumb. But it's a good place to start. You can sort of ask yourself as you're sizing up a problem and reading through the problem statement and saying, what is this problem about? The rules of thumb really want to be top of mind, so you can sort of say, like, is there any reason why this isn't just a very simple problem? And hopefully the answer is no, and you get to just kind of plug and chug and life is good. But there are going to be nuances, and there's going to be reasons why something's a little bit more interesting than that. And in this case, it's the ventilation piece that is the interesting part. But it's going to vary from one problem to the next.